everybody. Today we're going to be talking about the normal distribution. So the normal distribution is a specific type of symmetrical distribution that models a lot of real life phenomena, such as if I took lots and lots of measurements of people's heights, they would make this sort of bell curve. Same with like lots of measures of blood pressure, IQ scores, measurement errors, and lots of other things. So a normal distribution can be fully described with only two things. One is the mean. So we've talked about the mean. That's when you add up all of the numbers and find the average. Since it's a symmetrical distribution, the mean will be right in the middle. For normal distributions, the mean has a new variable. So the variable is the Greek letter mu. And the Greek letter mu looks kind of like a U, but it's got kind of a tail in front and a tail in back. And that's pronounced mu, mu. Okay? So it's not an M, it's not a U, it's a curvy U, kind of like a cursive U. Okay? And we also need to know the standard deviation. This standard deviation is a measure of how far away from the mean values typically fall. So the symbol for standard deviation is the Greek letter sigma. This is a lowercase sigma. And it looks like an O with a little tail. And the standard deviation is a measure of how far values fall from the mean. Right. So for a normal distribution, we have this thing called the empirical rule, and it tells us what percent of values fall within a certain number of standard deviations from the mean. So go ahead and draw yourself a bell curve. It's not very great, but you get the idea. Try to draw a nice symmetrical bell curve. And then a little x-axis here. So in the center, we have the mean. And then let's go out 3 standard deviations. So one standard deviation is going to be typically kind of where this bell curve changes shape. So I don't know, right about here, that's 1 standard deviation away. And then 2 and 3, these make them the same space. So this is 2 standard deviations away, and this is 3. And then go the other direction. We've got minus a standard deviation below the mean, minus 2, and minus 3 standard deviations. Okay. So normal distributions are special because they have certain percents between standard deviations. So if I go between 1 standard deviation above and below the mean, 68% of the data is going to fall within 1 standard deviation. If you go out to 2 standard deviations and see how much data falls within those 2, that's going to be 95%. And then if you go all the way out to 3 standard deviations, that's going to capture 99.7% of the data. So all but 0.3% is going to fall within 3 standard deviations. And this is only for normal distributions. So you can have other types of symmetrical distributions. I don't know what I'm spelling there. Distributions. But for normal distributions, they follow this 68, 95, 99.7 rule. All right, so if we're told the heights of ninth graders is normally distributed, I mean, it's going to follow that rule we just talked about. So with an average of 65 and a standard deviation of 2. So if I go up 1 standard deviation, that'll be 67, and then 69, and then 71. And then you go down the other direction, 63, 62, 59. So we want to know what percent of students are between 63 and 67 inches tall. Well, that's from 1 standard deviation below to 1 standard deviation above, so that's 68%. And then we want to know, well, how about just greater than 67%? So everything to the right of 67. So even past that 3 standard deviations. To figure that out, I already know that there's 68% between 63 and 67. So that means that outside, so if I look at this lower half as well, if there's 100% of all of my values, I can figure out that that red area is going to be 100% minus 68%, or what is that, 32%? But I only want half of that because I only want to know this area up here. So divide that by 2, and 16% is going to be above 67 inches. Right on. Last thing is to talk about what a z-score is. So a z-score is a measure of how many standard deviations away a value is from the mean. So our equation is going to be x, which is some observation point, minus the mean divided by the standard deviation. A z-score is also called a standardized score. So yeah. So let's say we've got 2 people, Ashton and Corey. Ashton took the SAT and got a 1380, and Corey scored a 32 on the ACT. We want to know who scored better relative to the others who took their test. So here we're given the SAT and ACT with a mean and standard deviation. And our observations are going to be 1380 and 32. So for Ashton, their z-score is going to be 1380 minus 1,000, all divided by 200. And that gives us a z-score of 1.9. Corey's z-score is going to be a 32 minus an average of 21 over a standard deviation of 5. And it looks like they got a 2.2 standard deviations above the mean. So that means they did better relative to the other people that took that same test. Awesome. That's it for notes today. Thanks a lot.